Welcome to Video 5 for this unit on functions and volume. In this video, we're going to focus on spheres. Let's consider a sphere. A sphere is a three-dimensional figure in which all cross-sections in every direction are circles. This sphere has a radius of r units and it fits snugly inside a cylinder. The cylinder must then also have a radius of r units and a height of 2r units. Using what we have learned about volume, the cylinder has a volume of pi times r squared times h equals pi times r squared times 2r, which is equal to 2 pi r cubed cubic units. We learned earlier that the volume of a cone with the same base and height as a cylinder has 1/3 of the volume. In this example, such a cone has a volume of 1/3 times pi times r squared times 2r, or just 2/3 pi r cubed cubic units. It turns out, if we fit the sphere filled with water inside of this cylinder, and then fill this cone with water and pour that water into the cylinder, the cylinder would be completely filled. That means the volume of the cone and the volume of the sphere add up to the volume of the cylinder. In other words, 2/3 pi r cubed plus the sphere's volume equals 2 pi r cubed. This leads to the formula for the volume of the sphere, 4/3 pi r cubed, since 2 pi r cubed minus 2/3 pi r cubed equals 4/3 pi r cubed. We can use the formula V equals 4/3 pi r cubed to find the volume of a sphere with a known radius. For example, if the radius of a sphere is 6 units, then the volume would be 4/3 times pi times 6 cubed equals 288 pi, or approximately 904 cubic units. We can also use the formula to find the radius of a sphere if we only know its volume. For example, if we know the volume of a sphere is 36 pi cubic units, but we don't know the radius, then this equation is true. 36 pi equals 4/3 times pi times r cubed. That means that r cubed equals 27, so the radius r has to be 3 units in order for both sides of the equation to have the same value. Many common objects, from water bottles to buildings to balloons, are similar in shape to rectangular prisms, cones, cylinders, and spheres, or even combinations of these shapes. Using the volume formulas for these shapes allows us to compare the volume of different types of objects, sometimes with surprising results. For example, here is a cube-shaped box with side length 3 centimeters and a sphere with radius 2 centimeters. Which shape has the greater volume? The volume of the cube is 27 cubic centimeters because 3 cubed equals 27. The volume of the sphere is around 33.51 cubic centimeters because 4/3 times pi times 2 cubed is approximately 33.51. So, a sphere with radius 2 centimeters has a greater volume than a cube with side length 3 centimeters. Thank you for watching video 5 of 5 for this unit on functions and volume.